Here we go. The notes on 5.4 are covering exponential growth and decay, and what I hope to describe to you today is how do exponential functions relate to growth and decay problems. What I like about this topic is it's used in real life. Almost every single one of you, when I say almost, I'm thinking it'll be in the neighborhood of 75 to 85% of you will deal with this at some point in your life in the future. If you ever plan on buying a car someday, most likely you're going to deal with this. If you ever plan on trying to make an investment, you will deal with this type of math. Math is used in real life. If you ever will buy a stock or invest or do something with insurance that promises you a certain rate of return, this is the formula that they use to figure that kind of stuff out. What growth is used in real life in dealing with interest. I want you to know that. I want you to know that this is where it's used in real life, okay? The formulas that we're going to use today is y equals a times b to the x power, where a is your initial amount and b is your growth or decay factor. Let me move that up a little bit and zoom in just a little bit so you could see that little section a little bit better. A is your initial amount. What are you starting with? B is your growth or decay factor. In other words, your initial amount, what you're starting with, is also known as your principal. How much did you start with? For example, if I go to the bank and I want to purchase a CD, a certificate of deposit, the principal is the amount I start with. I can buy a CD for $100, $1,000, or $10,000. It doesn't matter. You just have to have the money. Your initial amount is your principal. So this A here is the same thing as the P there in that formula. B, on the other hand, is your growth or decay factor. How much is it growing by? Is it doubling? Is it tripling? Is it going down? Are you doing half-lives in science class? That's decay, and so on. What the B in this formula is, the B is the same thing as 1 plus your rate or 1 minus your rate. And I'll talk about the differences of those two things as we go forward. I want to give you a real life example before we do what's on the worksheet, because I feel like it's more important to understand how you're going to see this someday. As a matter of fact, you probably have already seen it and maybe you've had questions about it. For example, the other day I was watching TV and I saw a car or a truck commercial that says you can buy this truck with 1.99% APR financing. Have you ever heard anything like that? Yeah. Okay. I'm going to use an example of a Toyota Tacoma four-door, and it costs $40,000. It's okay. You're getting distracted. If you see a car commercial that says that there is 1.99% financing, let me write that down. 1.99% financing. That does not mean that you pay 1.99%, because it depends. When it says APR, this means annual percentage rate. Annual means every year. Every year, you're going to pay 1.99% of that. So when I look at $40,000 truck, If I have $40,000, great, I can pay for it. I don't have to pay any extra money for interest. But if I don't and I want to finance it, I have to pay 1.99% on top of the $40,000 every year. Well, how do you figure that out? This is what we're going to do with it. We go like this. We put 1 plus whatever the rate is. The rate is this moving 2 decimal places to the left. 1 plus 0.0199 to whatever the power of t is. That's how much we are going to owe total with the car, with the truck, and the interest. I want you to see something just so you're aware. Just so you are aware, and you're going to be semi-educated as you graduate high school and you go out into the real world. Maybe the only thing you remember from math class will be this lesson. I'm not sure. We'll find out. Years will go by and you'll see if you remember or not. If you were to take $40,000 and do 0.0199, then I feel like car commercials and truck commercials are a little deceiving because you kind of think, 1.99% is only $796 compared to the $40,000. Well, that's not really how much it is. There are hidden fees. Don't forget that's annually, so you have to do that for how many years? For 5 years probably, most likely. This is what it looks like. Your initial value is $40,000. Your starting amount, your B, your growth factor is 1.0199, and most likely it's a 5-year deal. That's usually what the most car commercials or car places put out. So if I were to actually type this in, how much do you think it is? Let's do this. 40,000 times 1.0199. And I'm going to raise that to the 5th power because we're going to go for 5 years. That's how most of those terms are. Some are 6. This is going to say the truck costs $40,000 plus the money to finance the truck. Guess how much it's going to be? You probably have no idea. So I'm going to show you. How much does that truck really cost?
$44,000.
Equals about $44,000, 141.58 Oh, it rounds to 59 cents. I'm sorry. How is that legal? They share on there. Well, because they told you right. They said it's 1.9 per year. But guess what? It's how many years? 5 years. 5 years they get to add interest on that $40,000. This is how interest works against you. When you borrow money, you have to pay that in interest. If you ever want to make money, you need to be the one who loans or buys things that earns interest, like stocks, bonds, CDs, and other investments like that. So there you go. That's what I wanted to show you. That way you get an idea. So let's write down the next thing, growth. Let's get into our actual work. Growth. Something has growth when it gets bigger. Exponential growth looks like that. What happens with that is B is always greater than 1. If B is greater than 1, you are going to have a growth factor and the function will get bigger and bigger and bigger. On the other hand, is decay. Decay, on the other hand, gets smaller and smaller and smaller, exponentially. It's when your B is less than 1. If something decays, usually it's getting smaller. The most common place where we hear about decay is teeth. Teeth. When your teeth start to decay, it means you haven't been taking care of them, and they are starting to become, they're not nearly, they start to fall apart. Ugh. There you go. Got to take care of your teeth. This worksheet that we're about to do is going to start off very easy. This is the directions. Identify A and B. We'll do number 4 first. Identify A and B. Hi. Thank you. And we'll do number 4. I put number 4 in a box so that you remember that this is the exact same problem as number 4 on the worksheet. And so for number 4, it says h of x is equal to negative 3 times 2 to the x power. All you have to do on number 4 is figure out what is A and what is B. Now, I believe you can do that very easily. What are we talking about? We're looking at this. In this form, y equals a to the bx. How do I know what it's a and b? The b is the one that's below the exponent, and the a is whatever's in front of that. What's multiplying it? Okay? So here's what I'm going to do. I think that you guys get this, so I want you to say what a is out loud. Everybody say it out loud right now. Perfect, you're right. -3. Good job. A little late there, Riley, but good effort. Okay. B, on the other hand, is, say it out loud. It's not to the x. B is the growth factor, not to the x power, just 2. Just 2. Okay, so I'm glad that I heard that because that lets me know what I need to correct. That's how easy the first 4 problems are. There's one that is tricky. It is number 3. So we're going to do number 3 together as well. I'm sorry. Nope. That's not it. That's not number 3. G of t. I'm sorry for you perfectionists. That's how it goes. Blake, stop. Number 3 says G of t is equal to 6t. 6 to the t power, I should say. Now this one's harder because you have to figure out what is A and you have to figure out what is B. I don't want you to say this one out loud to me. What I want you to do is I want you to tell the person who's sitting either in front of you, beside you, if you don't have anybody next to you, so to the people to the side, what you think A and B are. Discuss. Okay. Good discussion. I heard lots of right answers. The 6. Is it A or is the 6 B? Say it out loud. B. It's B. It has to be. Let me show you why. For anybody confused, if I go back up to here, the B is always the thing that's below, is the base of the exponent. So when I look at this problem, here's my exponent. What's at the base of the exponent is a 6. That has to be your B. Now the A, I heard some correct answers and I heard some incorrect answers. So let's just hear how many different answers. What did you think A was? Say it out loud.
62.
1. 0.
If you said 1, you are correct. Lots of different answers though.
There's one difference.
Think about this. Shh. Quiet down, please. What are we multiplying this 6 to the t by? Riley? Shh. Thank you. What are we multiplying this by? We're multiplying by an invisible 1. Whenever you don't see anything in math, it's always an invisible 1. It's very rare that it's not those two things. Okay, so after we have problems like that done, there's several other problems that are going to ask you to plug things in. And I think those problems are easy to do, so I'm not even going to give you an example. You just have to read them and do them. The hard ones are going to be like number 7, and I need to walk you through how to do something like that. Okay? If something earns 4% interest, if something earns 4%, then that means your rate is when we move a percent to a decimal. Do you remember how to change a percent to a decimal? Move it how many places? Which way? Okay, so this is 0.04, by the way. So let me show you 4%. I'm going to write it off here to the side. There's an invisible decimal place that's right to the bottom right, and then it moves to the left 2 places, which means we have 0.04 is our rate. That's not B. B will equal 1 plus the rate. That's what we wrote down earlier. So if I want to know what the base is, when something earns 4%, the base would be 1.04. That is literally the hardest thing for me to get you to remember. What I want you to think about is this. If I buy a CD for $100, I don't just want to know how much interest is going to accrue. I don't care just about the 4%. I care about how much do I have plus the interest. Literally, I can't touch that money, but I know how much is there. When I have a bank account and I go, oh, I have $1,000 in that bank account and it's earning this much interest, I want to know how much is there plus the interest. So that's why we do this. The 1 plus the rate, so we know what the total is. And that way we can figure out over the life of it how much growth we might get out of it. Okay? So here's what number 7 looks like. I'm going to write number 7. And this will be the only example I give you, and then you guys will start the worksheet. There's $5,000 principal earning 4% compounded annually after 10 years. $5,000 principal earning 4% compounded annually after 10 years. I know that some of you will look at this and say, I'm never going to have $5,000. Well, guess what? Some of you will. And some of you, no. Some of you might take a car loan out and you'll pay a lot more than 4% for a car loan. A lot of times, most depends on your credit. If you have good credit, you can get financing around 6%. That's pretty good. If you have really bad credit, you can pay 10%, 20%. If you go to a credit card, you're looking at 25% interest. And it's a lot of money to pay on top of not having a lot of money. So keep that in mind. This is real life stuff here, and it's math. This is how math is used in every day, especially here in the United States. Okay. $5,000 principal earning 4% compounded annually after 10 years. What you're going to do is you can use either this formula or you can use this formula. It doesn't matter. They're the same thing. A is your initial amount. P is the principal. B is what your growth factor is. The B is the same thing as 1 plus R. So it doesn't matter. Here's what we're going to put. We're going to put down that our amount is, after 10 years, what's our principal? Times? Do you agree with what he just said? What goes in the parentheses? That's the hardest part. It's earning 4%. Don't put 0.4 in there. Don't put 4%. Put in 1.04. Why is there a 1? Because we need to add the original amount as well. After how many years? 10 years. It's compounded every 10 years. You could take this, and by the way, 4% existed about 18 years ago. There were some CD rates that I actually earned 4% on. It's awesome. This doesn't exist nowadays. I can't find anything that's earning 4% unless I go stock market or individual company. Okay, and that's just my personal investment advice as we go forward. 5,000 times 1.04 to the 10th power. $5,000 after 10 years of not touching it and it earning 4% every year. Guess what 5,000 turns into? $7,401.22. If you want money to earn money, letting it compound year after year after year is one of the easiest ways to make money, but you can't touch it. It has to grow. This is one of the reasons why people who have a lot of money, their money just grows and works for them, not against them. And so that's what our answer is. That's what it's worth after 10 years. We're going to stop our notes right there.